welcome everyone to the Hive. I can see some new faces. So for those of you who haven't been here before, the Hive is the university's visualisation facility, and our role is to support and encourage the use of visualisation technologies and tools in research projects right across the university. We're actually coming up to our 9th birthday, and it was just over 8 years ago that you were here last.
Yep.
So I'd like to introduce David Newman, who is our special guest today. He's flown all the way across from San Diego. You might recognise from the accent he's actually from Perth, but has been in the US for quite some time now.
Yep.
And tonight he'll be, I can let the cat out of the bag now, he will be receiving an alumni award tonight. Congratulations to David.
Thank you.
David Newman is, what was the term? Technical Fellow. I can remember that off the top of my head, of course, at GoPro. I think you were saying you could introduce yourself, no?
I'm sure I could. I've been at GoPro for 11 years. It was through a startup that they acquired, and I was in charge of all software development at GoPro for the first 5 years, and then started getting involved with some more of the camera development and advanced technology group. So I transitioned into getting rid of all the burdens of management and becoming a technical fellow at the company, and we'll talk about some of the things what that involves, and it's been a great time.
Yeah, so as it turned out, we both started our degrees in the, at that time it was the School of Electrical and Computer Engineering in 1986. And so I was going to ask David, what do you remember of your degree all those years ago? And how do you think it's set up for your current career or your career path as it's progressed?
I'm sure for the first dozen years after finishing that degree, I thought none of it applied to what I was doing, because I had taken, for my project, my final thesis project, it was all related to media. It was some students were working on a hardware video frame grabber. Just pulling a frame from video was hard back then, and I was working on the software. But I didn't learn to code through the school. There was like one lecture on the language that I ended up at.
It's probably in Pascal.
Oh, we did learn. It was one lecture in C, and that's what I ended up basing a lot of my career on. And so at first I thought, well, I probably did the wrong discipline. But in much more recent years, everything I've been working with has involved complex embedded systems, hardware. I have to look at schematics. I have to help debug things that are going on. I have to deal with thermals, optics, all these sort of much more broad engineering-focused things that so much of my undergraduate work does come into play. And so much of what I did in that original project, because I was working with others that were building a capture card system, which ultimately didn't work, but I had to work out why it didn't work and help understand that, and that's kind of what I do now. It continues to be to this day. So it's very much a hardware-centric electronics but I'm a software engineer.
So as I mentioned, you've been at GoPro for 11 years now, which is eons for a startup, of course. And you're now one of their longest staff members. You were just telling me earlier that they're up to staff number 4,000 something or other now.
4 or 5. I keep on seeing the new guys, and their numbers are high. And yeah, so when the company was acquired, my startup was acquired, I was the 75th employee of total. And people, at the time there might have been 50 people in the company, but some people had left. And so yeah, I think there's only a few of the numbers higher than me that are still with the company. So I am the longest term engineer in the firm.
How's the technology changed at GoPro over those years?
I think from the outside world, everyone always thinks of us as a consumer electronics company. But when I started as an engineer at the firm, there wasn't really anybody who did electronics. So we used a lot of reference designs, and it was much more about the mechanical They built dive housings. They make cameras waterproof. They built the mounting system, which is, everyone recognizes a GoPro mount who's dealing with other camera systems. There's either the classic 3/4 inch camera mount or is the GoPro mount for small cameras. So the first engineer I met within the company was a mechanical engineer who designed the mounting system. But now we contribute to the SoC design, the system on chip. We design pipelines for how video and pixels are processed and how CNNs, computational neural networks, are added and dealing with mathematical denoising of image. All of that's done in-house now. None of that existed when I started there. So it's grown from much more of a ideas and marketing company into a serious engineering firm coming up with the latest in very small form factor imaging technology for consumers.
So one of the first things that caught my eye about GoPro was essentially their 3D camera rigs, which was 2 synchronized GoPro cameras. And things have, of course, evolved a lot since then. Do you want to sort of comment upon, actually I should
bring it up.
We've got it up there.
In fact, the reason the startup that I was involved with was acquired is we were working with post-production in 3D and making consumer cameras that GoPro was, they wanted to make sure that people could actually make content in 3D, so that they acquired a software company that dealt with that, because it was hard and harder today than it was then even. We were trying to make it easier, and so we got involved with coming up with the ways to genlock the 2 cameras. The cameras are independent, you purchase them separately, and then you could put them in this housing in which the cameras would then sync up and produce pretty compelling 3D, given the kinds of immersive content that GoPro was capturing. A lot of POV, a lot of perspectives from people doing exciting things, going down mountains at extreme speeds and things like that. To have that in 3D was some of the best eye candy 3D at the time, because traditional film and television, film acquisition was larger rigs with beam splitters. They weren't really able to get right outside the action. In fact, the separation between the lenses was designed because we realized that so much of the immersive content we're creating is so close to the lens that we need to make it not painful to view. So that was what I worked with. I worked with the hardware team. This was our main project for that software, is make sure that people could edit this content.
And so this housing would go down to, I think it was about 10 metres?
Yeah. Oh, I think it was, 60 feet or something like that, or whatever I think it went
20 metres.
20 metres, yeah.
Yep. So that wasn't quite enough for us. So we built a housing that would go down to 3,000 metres or 9,000 feet. So we actually used 8 GoPro cameras on the survey that we did of the shipwrecks, the HMAS Sydney and the German vessel Cormoran back in 2015. So I'd be interested to know whether there's been any cameras that have gone any deeper than that. Any GoPro cameras, of course.
I'm sure they have, but we've never seen them again.
These ones we got back.
Yeah.
And the footage. Which
there's always a found GoPro story, but anything that's sunk without one of these housings, they're not recovering the media.
Yes, yes. So if anyone is interested, we have 2 of our deep water mounted GoPro cameras sitting on the bench over here. And so I guess the synchronisation of 2 cameras transitioned into synchronising multiple cameras. Do you want to sort of comment about where that led?
Well, once we worked this technology out, we were very excited, the idea of building kind of a Lego system where you could just build, the cameras are your base brick, and you can build camera systems that were more complex than that. And we imagined, so we actually did build a 3-camera stereo rig. Never commercialized it, but we actually did experiment because it had several different distances, so you can choose your depth budget based on switch between cameras. All 3 were in sync. Then we ultimately built a 6-camera and a 16-camera rig. The 6 camera was our first foray into professional 360 imaging. It would stitch a complete 360 that way, 180 degree that way. In other words, there's no holes in the world.
So bring up that.
That's the Omni rig. And we also partnered with Google to build a light field camera. So this is 360 by 120. So it didn't see straight up or straight down, but it was for Google's efforts. I can't actually remember the name of their VR experiences around the world.
Dream something. There was Dream something, yes.
Dream something. And what this was, this allowed stereoscopic immersive a VR experience. You would take the 16 camera content and would upload it to massive amount of Google servers. It would take 24 hours per 5 minutes of content to compute the light field, which is a way of basically computing the 3D or the depth map for the world, and then they would make traditional stereoscopic output for people to then explore within VR headsets. We built it for, probably about 100 of them were made. These rigs were sent around the world and put into rainforests and lots of exotic locations to document very, very high quality stereoscopic imaging that people can explore within headsets.
Yeah, so it came to me. It was Google Cardboard first.
That was the little modification.
Yeah, the little mod, but then it was Daydream.
Daydream,
which used the Google phones.
Yep.
And so this work then transitioned into the 360 camera rigs.
It did, and I remember the reason I was going to put the next slide is that one of the things that I was involved with this is that all of these cameras need to have unique IDs, and because these cameras are consumer cameras, each one of them is the same one we sold to somebody from a Best Buy store. While they were running custom firmware, they were mostly the same. Most of the electronics was actually inside the housing and in the backpacks that were attached to the cameras. So I was involved with making sure all the metadata worked. And there was no standard way of IDing cameras, particularly IDing a camera within a camera rig. So we proposed a metadata system that became the backbone of everything we do in terms of collecting data from our cameras today. But these are the first camera rigs that had embedded metadata. And when we shot this, when we made this, the first thing we realized, this thing needs to have an IMU. And then of course every camera we've made since this has an IMU.
And everyone in the audience knows that stands for an inertial measurement unit.
Yep. The device that makes your phone work out what orientation it is. But once you realize that they became mass market and really accurate, then you can do some really interesting things with them.
Yeah, so that brings us to this slide.
Yeah, so it's not the most compelling slides, because I just wanted to say images of data. Metadata is not particularly good. So I came up with a fairly simple key length value system, but the system was much more complicated because when we added IMU, so accelerometer, some cameras have magnetometers, gyroscopes, which is very important for stabilization. These devices, these consumer devices, weren't designed to be synchronized with video. So as you're used to having video and audio synchronized, you hope that when you hit these cameras and you hit record, that in an hour the audio is still in sync with the picture. There's a reason for that. They're running off the same clock. That's not the case with every single third-party consumer-like device, IMUs, GPS units, even just stuff coming from Bluetooth. Everything's running off their own clocks. So the idea was to come up with a system that we could store anything any engineer within the company could come up with, any kind of cool telemetry collecting device, and be able to synchronize that with content without having to change the hardware to have everything running off the same clock, which was going to be a design nightmare. And so so I came up with GPMF, which was GoPro metadata format, but we call it general purpose metadata format because we made it open source and public. Other camera vendors can use it. And it's been a super win because a lot of vendors now use GoPro cameras for data collection because this is all open source. They can then use that to understand other things. We have a lot of scientific applications for using our cameras, and this just as a data logger where the image may be secondary to the data they're collecting from other devices.
This led on to the 360 cameras,
Yes.
Of which we have a couple here. You want to say a bit about those and the type of content that sort of enables?
Yeah, so these were very heavily metadata-driven cameras. You wouldn't be able to use either of these without the kinds of telemetry that they collected. The first one we introduced in the market is GoPro Fusion, and it's technically the 3D camera system. There are 2 cameras inside that. There are 2 SoCs. There are 2 SD cards, and all the metadata allows the synchronization between the 2 cameras, and everything was done in post. But all the stabilization became like synonymous to, starting with 360, then moved into our regular cameras, was driven by 90% the IMU. There's some sensor fusion going on, but the IMU allows us to understand camera orientation and to sub-pixel, given that these cameras were both over 5, this is like, they're both about 5.6K in resolution, and but then we can stabilize and work out the camera orientation so that we can move any of the images within like a tenth of a pixel kind of precision from the IMU. That's how accurate these devices had become. And we moved from this camera where we kind of used it as a prototype for, it was in the market, to realize what could happen, and then Max replaced that. We have one over here, or Andrew has one over here, I didn't bring it with me, it's part of the Hive, and made it much more consumer friendly. All the computation for the stitch is performed in camera, but we don't need to stabilize in camera because we don't know where you want to share your story. We don't know whether sideways or front lens or pointing straight up is the most interesting part to tell. So we leave all of that up to post. You will stabilize and you can punch out any viewpoint you'd like to tell your stories and share. So while a lot of people were thinking these cameras came out at the same time, like Facebook was buying Oculus, and they go, oh, we're going to have a VR camera. No, that's not the point. VR is actually a pretty poor use, the cross-section of this type of camera, because you want, not the resolution's good, but you want really high frame rates so you don't get the judder of you moving your head around. Whereas these were designed for regular video sharing in Instagram, social posting and so on, where you have this massive amount of resolution, but that meant you had a good amount of resolution everywhere. I think we've got some examples of that.
Yep, so we'll just play a couple of those clips. In fact, I can upload that other one. Whoops.
Oh, yeah, you forgot. Yeah, this is, unfortunately, it was a rip from a
Instagram page.
So it's actually much lower resolution than what we posted. But this was, it's full HD when you see the original. And this was actually an experiment with something else that we were doing later, where I was having a camera run for 24 hours. But the camera's not in motion. It's all just done with keyframing from the original static camera, just on a tripod. In fact, you can just see the legs of the tripod because it sees everything, including what it's mounted on. And then the next one was just me and my daughter showing, I am not moving the camera. So I was holding it on a pole about this far away from my hand. And we probably could have trimmed off the beginning of this, because what I would show is that I started using it just through keyframes and a regular video editor. So, and then all the kind of virtual camera moves are done in post. So when I choose what viewpoint that I want to show, and so I'm reaction shot, moving around, telling the story, and this takes a few seconds on the mobile app to actually do. But you may actually notice that all that motion blur is all computed, so computational motion blur, all these things to simulate like a cameraman being there, but you don't need to bring a cameraman with you when you have a 360 camera. So they actually stopped the last frame, showing that the computational motion blur is really inseparable from if I actually shot it with the camera and I actually panned around, had a long shutter, and so we simulate all that in post. And I was the author of this filter. that created all this. I wrote the original engine that got ported to their mobile app and so on. I still maintain it on the desktop.
And so you were mentioning earlier that you also, I should mention that David is a regular participant in the 48-hour film festival, at least in the San Diego Region 1, and you use this technique for one of your 48-hour films.
Yeah, as I'm passionate about filmmaking, and so working at a camera company is a really wonderful experience. And I knew that I was actually going to make a short film with a bunch of teenagers that really didn't know how to focus a camera, let alone set up lighting and so on. So I thought, let's make it easy for them. That I said, we'll use a 360 camera and it will be face mounted, and they will act amongst themselves. So it was a first person movie. But all the visual effects, because they're going to sometimes move the wrong way, all of that was done in post. And because it's an extreme filmmaking competition, it had to be done within very tight time frame, so it had to be easy to do. And so all the gyro data and the camera orientation data was actually passed into things like Premiere Pro, and I just all keyframing edited the whole movie within the crazy time frame that these things are. But I knew I was going to do this, so I actually created this filter ahead of time, and that's the filter that GoPro ultimately shipped. It was something I created for my daughter's film competition. So yeah, I often tie personal interest with what ultimately becomes functions within the company.
It's good to have that motivation.
Yeah.
Now, last time you were here 8 years ago, and people can look at the video. For those watching it on video, we might have the link here, or here.
Supposed to go. Click here.
Yeah, somewhere. And you can watch that. You were starting to experiment with some of the custom firmware solutions for GoPro, and that's really taken a big leap now.
Yep.
With Open GoPro and GoPro Labs. Do you want to say something about those two?
Yeah, so I lead up the GoPro Labs initiative, and Open GoPro is actually a much more recent. It actually came out after Labs. What they both are is enabling some of our more advanced users to use our cameras in markets that we didn't plan for. So, if you're a snowboarder, we know the kind of user you are, we have features and resolutions that are appropriate for that activity. But if you're shooting underwater objects at deep sea, or if you're doing extended time lapse, doing building construction, that is not our regular user base. And typically, people would work out their own solutions, but there wasn't really any direct support from GoPro, because it's a vast market in which people can use cameras, of course. So GoPro Labs was an idea that I had. We have internal hackathons in the company. It's great for engineers, and actually non-engineers are involved as well, where you come up with some unique idea for the camera. And some of those hacks, it happens like the competition. You have 48 hours to go and quickly come up with, you're told you don't have to do anything else at the office, come up with a hack, and then they're in competition with each other, all these hacks. So it's a lot of fun, very much engineering. It's a sort of exciting thing for geeks to get involved with. And I started collecting winners and losers. I thought that was a good idea, but some of these ideas didn't make it into the main product. They're just because market for it was too small, or was technically at the time not feasible to put into the camera. But I collected them, and I, for a number of years, started collecting all these ideas into one piece of firmware that I would move from camera to camera. And then there was just a time when we realized, well, maybe we should release that. And what should we call it? We'll call it GoPro Labs. And so this collection that I maintained, we used it internally. It was just that we weren't shipping this publicly. And the way it worked was I used QR codes to enable features that were invisible on the camera. So, and there are now hundreds of little hacks that just do some odd little things that are important to certain types of filmmakers. And I say filmmakers, it's not always filmmakers. But, so whether that would be, we were doing stuff with NASA, and we're doing stuff with Disney, and these great exciting names, but fairly minor little hacks that would just make the camera work. And the very first project was for a International Space Station supply mission. And they wanted to document the launches. They want to put cameras around the launch pads. But the problem is the people who are the photographers and videographers for these events can't get access to the launch pad. The last time they can access is 72 hours before the rocket takes off. You know, they're loading fuel. It's just not safe for them to be there. And traditionally, they have placed larger format factor, DSLR, DSLRs and so on around, and they've had audio triggers. So what happens, the camera's just sitting there waiting, and then when the sound pressure level hits a certain amount, it fires the camera up and it goes trigger, 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 trigger. And so you get a lot of photographs, but they tend to go wrong. Other sounds can go off and they can fire at the wrong time and so on. Well, what we did is there's such a small launch window, we modified the firmware so there's a wake timer on the camera. It's not used for anything else, or at least at the time it wasn't. That we could tell the camera to wake up in 72 hours and start recording in whatever video mode that you chose. And you just told the instructions about what time to wake, what video mode to shoot, how long to shoot. As a single QR code, we come up with a language that can communicate all the camera commands as a QR code.
Which you just flash into front of the camera lens.
Yeah, the camera then tells you on the screen what it's going to do, shuts down, and then 72 hours or whatever number of time you wanted would actually perform that operation. And so they ended up getting better launch footage than they typically do on these. They had cameras in dive housings sort of just under where you got smoke and flame and stuff was coming. You know, if they melt a housing, it doesn't matter. The cameras are inexpensive, so they can put them in much more dangerous situations. And this was a huge success. When we see it through this, the number of downloads and people asking, you know, the constant more and more features. So that's a great way of us innovating, getting our customers to tell us really corner case things that we just wouldn't normally be able to support, but this is an avenue for us to support that. But installing custom firmware is not for everybody. So OpenGoPro basically opened up all the APIs for camera control that we ourselves use within our mobile app and our Bluetooth devices that control the camera. And now we just make that completely public so that if you want if you're a manufacturer who doesn't manufacture cameras, you maybe you have you manufacture a product, car, boat, whatever, and you wanted to have camera controls within the dashboard of your vehicle or whatever the systems is, some live streaming services and things like that, they can now directly control the camera and make it work as a device in their system. And that's just through OpenGoPro, which we publish and keep things active on GitHub to show what camera controls are available, and as the cameras go through new revisions, we provide more controls. And so that is basically, if you want to control the camera via wireless or wired connections, you can use exactly the same protocol as we use internally.
And every time I speak with David, I think of new ways I can be developing some underwater cameras, of course. And I have to try some new things once I get some time. Of course, another area for small cameras is drones, which this is an example of. You were mentioning the other day that if you can keep a drone, the whole thing below, I think it's 250 grams, which is pretty light, then it avoids many of the more harsher restrictions on drone use.
Well, yeah, if one of these things were to fall out of the sky and hit you, you wouldn't be pleased, but you would be dead. So, I mean, some of these bigger drones are definitely a reason they have to go through a lot of certifications, whether it's CASA or FAA or whatever. There is a lot of laws around drone uses, but even even for legal flying, even above 250 grams, every ounce, every gram matters. Because how long these fly and how far they can fly depends on the weight of all the components that are not, obviously rotors and motors are important to keep the thing flying, but battery and cameras are cameras about why you're flying, to capture some particular interesting angle in the world. So the particular type of drones this applies to is the first-person video drones, FPV, where people wear goggles, see the perspective of the drone, and they can fly at a much higher precision than if you're seeing a drone 100 meters away from you. You see a dot in the sky, you don't know which way it's pointing or where it's going. But, so there's actually two cameras in these systems. The small camera here is delivering like a 720p at a high frame rate, 60, some of them do 90, 120 frames a second to get very, very high latency, low latency, high control. And then you have your cinematic camera, which is so often a GoPro. And this happens to be a third-party company that produces drones. They also dehouse, that's a Hero 8. And so, and what we found is because they don't have any screens on them anymore, there's no touch screen on the back, these guys were using labs a lot. And I started to follow along on their different communities and how they were modifying their cameras. And I started making, in-house, I did the same. I had cameras that I took the screens off them and I started to code for cameras that didn't have the typical peripherals and saw, yeah, I can make this better. So within Labs is now fully aware of what they call naked configurations. Oh, here we go. And so we decided to build a camera for this market. And this is the very first kind of Labs hardware because it's got the same sort of mindset around what Labs is. It's a little hackish. It was done very quickly. It was done it uses a regular Hero 10 motherboard, and I say hackish in the fact that it ran Labs firmware from day one. We knew that they would need QR codes to control it. In the little quick start guide, it says this is a recommended mode for FPV. You just you put power in. No battery, because you don't want to carry a separate battery. You power it off the drone. The camera uses only like 2% of the power the drone does to stay airborne, so it's tiny. So why put an extra piece of weight for the drone to have to lift? And this is just simplified down to, instead of a 150 gram camera, like this is a Hero 10 on a little hand grip, but the camera itself is about 150 grams of battery, so that's around 50 grams. But it shoots exactly the same modes. And it's vented because we know it's going to be airborne, so we don't need to worry about thermal heat sinks nearly as much. In fact, the battery is part of the heat sink design in our cameras. We need a mass to suck up energy to make the cameras run long. It's hard to get that much resolution and that much frame rate in such a small package. And this was losing so much of its thermal mass, but it's designed for aerial. So I got to lead the firmware on this project, and it was super fun. I'm an enthusiast flyer myself and experiment with modified cameras and these.
So let's just show a quick sequence illustrating the teardown
This is
of the
our
camera.
promo for the Bones camera.
And also some of the resultant footage.
Sadly, you can't buy it in Australia. It was a US market only thing, but when you visit, you pick them up from there.
Pick up a dozen. So we've spoken a lot about cameras, the hardware, the firmware, a little bit about capture, but you've helped a lot of filmmakers achieve their goals. You want to mention some of those collaborations?
As I said, I'm an amateur filmmaker myself, and often, because of my experience at a previous company which basically did what they call digital intermediates, it was a way of storing high quality. We had so many of the stereoscopic films and IMAX films go through those workflows. So I knew some high-end production folks. And what would happen in the early days at GoPro, filmmakers would say, I'm trying to use your camera, but I've got this feature film project. and they would often end up at my desk or on my phone. I'd love to talk to these guys. And one example that was super fun project to be involved with was the first, it was going for 100% POV feature, and it ended up being like 99% of the content in the movie shot with a GoPro. And the filmmakers, they'd never made a feature film before, but they were a rock band, and they made their own music videos, and one of the band members had a Hero 2, so that's 10 years ago in terms of technology's about, about that. And they shot this video that went viral, and an investor said, here's $2 million, make a feature film out of that. They didn't care about the plot. It shows a little bit in the movie, but the idea was that they were going to make a feature film. And they just called and said, look, this is not possible, is it? There's no way you can do this first-person experience using a GoPro camera. And there's always a question about, well, films are made with these very expensive, large cinema cameras, but ultimately there is very little difference. There's some dynamic range, there's some noise profile differences, but the resolution of this is higher than most cinema cameras. It's just this weird world we live in, where we're producing, this one produces 5.3K at 60 frames a second, or 4K at 120 frames a second. Really incredible specifications. When you look at an Alexa camera, which is what shoots most film and television, it's 3K at 24, or maybe at 60 if you push it. So there is definitely a difference between those high-end cameras, and there's reasons you want to shoot them. But they were in our sweet spot. So I convinced these filmmakers it could be done. And I sort of they were a long way away, so it was via Skype, talking with the cinematographers who did not speak English, so I had to go through translators to talk about how this could be done. And the reason I was able to give them confidence, I says, we have another camera that was about to come out. They did not know, got them under NDA, so they were going to be introduced to the Hero 3, and a lot of the problems they were having were related to lens distortion, and we gave them a lot more comfort. And that's when I started getting into customizing firmware, because they were asking for things, and we go, oh, with a little tweak in firmware here. I wasn't the one coding it at the time, but I would know what the feature was, and I would ask, get a favor from an engineer. They knew it wasn't going into the products. Like, of course, they'll do it on the sides. We did that and made a pretty entertaining film come into existence that I feel that probably wouldn't have looked as good if it went with another camera. And so that was super exciting. So if you ever want to check out the very, very over-the-top, ultra-violent, hardcore Henry, it was a bit unfortunate because we couldn't really promote it because our brand wasn't really associated with extreme, that sort of extreme, but it was a lot of fun to get involved and help filmmakers create. And I do that today, working with filmmakers making documentaries or...
Yeah, so I just looked it up the other day. It is available on a couple of different streaming services, yeah. So thanks very much for joining us today. I guess just one last question off the cuff. Where's this all heading? Well,
I can't tell you what we're doing next.
No, we haven't got NDAs for everyone. So.
Yeah. We know that computational imaging is a strong part. We see this on our on cell phones that have multiple lenses, so they're doing computational things to create those images. We're doing computational things in our cameras right now where you take a series of images to construct a great image. The super photo is exactly that. The camera does a bunch of it. So, and also AI engines. There's an AI engine in our camera. How you use that, what you load the neural net is there's a lot of possibilities there. And I just think that the characteristics of camera optics and how light falls on a sensor is kind of old school, and that we are going to be doing a lot more in terms of image enhancement for storytellings that are using AI-driven solutions both in camera and in post. Because we at GoPro have just as many, I don't know the exact count, people working on how the image is delivered and how the image is taken off the camera as we do for people who create the image on the camera. Because that's only part of the story, it's collecting the data. You want to collect as much information from the world as you can, but that's not, you don't just dump raw data into someone's inbox. You want to actually tell a story which involves editing and involves shot selection, and we want to make that. We already do AI-driven for almost all of these things. It's going to continue along that path.
Well, please join me in thanking David, and congratulations on the award tonight.
Thank you.
So, yes. Are there any questions from the audience? There's one just down the front here. Just wait for the microphone.
Oh, making it all official.
Yeah, I had more of a technical question surrounding the Hero 10 bones about the drone. I noticed you had it looked like a mini USB-B or something into the camera. You said it was overpowered. Does the drone transmit any data to the actual camera, like any of the onboard sensors or IMUs on there?
No, it is one of the. I would like to have the camera be a data logger for the drone, because the drone has its own, obviously, IMU that makes why it flies. So there is camera control. There's a signal that you can, Betaflight, that's the flight controller firmware that's most commonly used for drones. And you can set I/O events, so you could have, from your remote control experience, you can tell the camera to start and stop recording. But it's pretty limited. We went that path because that's what people were doing. That was what is expected. It will be a little more education for users to say, hey, here is a command sequence where you can change exposure rules on the camera and stuff like that. But I would like, a future version of these cameras to have just a general purpose, serial port, I/O to the camera, be able to put. But this is my wish. It's not like I'm promising it's going to happen. So it's. I think that would be very cool, and it hasn't happened yet in the market, but it seems to me we already have some of the best, I think it actually is the best data collection, metadata engine, and we could pull in other data, and the drone is a perfect source for that data. We did it ourselves when we built a drone. We used GPMAP to store the drone's flight telemetry, and it was public and people could read and learn the path the drone took and so on. It's just that we have to now do it with open source community flight controllers and make it available everywhere.
Cool, thanks.
Any other questions? Ian Parnham?
Oh, a really interesting talk. One observation, I'm interested in your comments. I could get this wrong because I'm not all over the different GoPros, but each generation you get more and more megapixels, the image resolution increases, but the sensor size itself has stayed relatively the same size. Are you able to kind of comment on the process, the development of that?
Yeah, there is a desire to have a bigger sensor, because we understand that as pixels get bigger, you get better dynamic range and lower noise. And certainly low light, that's a criticism. It's a reasonable one to say, GoPros aren't really great in low light. It's a nature of the sensor, and the problem is the camera gets bigger. Simply if you put a larger sensor in there, we have to have a bigger camera that weighs more, because physics keeps on getting in the way. It's just physics things are super annoying, and that
Can't change the laws of physics.
I learned the term quantum diffraction limits from GoPro. I didn't know that. I'd never heard of that term before, and now I understood what was going on that was preventing, some of the, you can imagine what type of lenses. So that is why computational denoising and things like that become a factor. If we are making small cameras because they're wearable, pocketable, you can't suddenly put a bigger sensor in it. And same with cell phone vendors. They could put a big lump on the side of the cell phone and have a bigger sensor and have more, but they're mostly solving their noise issues with computational methods.
I just had a follow-up comment on a different topic on the interesting rigs. Just more one of my favourite examples. is some of the wildlife examples where they've looked at kind of trying to, I guess it might be some form of 4D photogrammetry where you've got a moving target but enough cameras that you're able to capture. And I've seen one with I think it was Steve Backshall on one of his Steadily programs with a GoPro rig with I don't know how many cameras to image the shark. But I think that was a real interesting application of them.
We talked about that in the last session. We talked about some of the array camera systems. It was really early in my career at GoPro, where you had like 48 cameras and stuff like that. I actually wanted to build one of those arrays myself. I'm sure I'd use it for a short film project, but I have never managed to have the time to wire
48
it up.
cameras for 48 hours, yeah.
Oh yeah, but and then you basically do matrix bullet time from those sort of systems, and you can roll around the subject. And we did a partnership with Rip Curl and had an array out on a guy with a jet ski, so you could see as some surfer was like doing some stunts on top of the wave, and then you moved around the subject, frozen in time. So you know, to think that they went from the kind of rigs that they shot with the Matrix to actually be able to take it out onto a jet ski. It was a lot of fun. They're expensive rigs to maintain, so it's not a product we ever commercialized. We partnered with various companies doing high-end commercials to shoot that sort of rig.
So if taking up that photogrammetry 3D reconstruction theme, it was a GoPro that we used to survey the wreck of Australia's first submarine, the HMAS A1, which we've got showing up on this screen here. So for those in the room, stick around and have a look at that afterwards, and have a look at the cameras we've used for that. One of the things we dearly wanted with that camera was to just be able to turn off the automatic white balance, and it wasn't possible at that time, but I'm sure it would be now.
It's totally not possible. Yep.
It's great how things evolve over time, and so I think with that we're nearly at time. So again, we'll put our hands together and thank David.